is Yuan Su.
Thank you very much, Peter. I'm still surprised this is the first conference that L2B organized. It's really well organized. A lot of talent in your team, I can see. So my name is Yuan. So I'm the co-founder and tech lead at Metis. So very nice to meet all of you. I don't like to stand behind the podium, so that's why I'm walking around. Hope you don't mind. I did update the slides because someone shot something in the morning. So yeah, I do own some explanations. I thought my article that I wrote a long time ago was a good enough explanation of what we did about the data availability. Apparently, I'm a very bad writer. I think there's a lot of confusions and misunderstanding of that. So I'll take this opportunity to explain again what we did to reduce the gas cost to a minimum. So ignore my, it's not working. Do I have to go closer? Ignore my graphical slide. I think when I updated, I got the order wrong, but this is my slide to start. So somehow, in April, Metis have done a big update to reduce the gas cost to around 15 cents per swap, 5 cents per ETH transfer. How is that possible? That must be some security trade-off, right? That's people's first impression about it. But I would like to introduce a new concept called optimistic data availability. So what it means, so to start with, we assume the sequencer will make the data available. That's assumption, optimistically, right? So if everyone's behaved perfectly, honestly in a system, so this is the lowest cost because you don't have to deal with the availability cost. You have to roll up to L1 all the time. And there's another important mechanism I do want to highlight in Metis that is only possible in Metis so far, is the sequencer role can be paused through a voting. There are multiple tiers of voting. So a sequencer role can be paused for 10 minutes, 30 minutes, hours, days, depends on the consensus from the community members. So it depends on the number of voting going on. So that particular mechanism limits the cost that eventually we need to incur if a bad sequencer is in place to submit wrong states and wrong transaction information. And third, the verifiers can actually request data availability. So what it does mean is we optimistically assume it will be available. But if we found the data is actually not available, the verifiers can request the sequencers to make available on layer 1. Basically, it's a delayed rollup. Okay? So when that happens, I think that neither the verifiers nor the sequencer will benefit from this data request. So they all lose. So in their own interest, I'll talk about sequencers that does have other agendas that we want to make the data unavailable. But in most cases, no one wants to have this data request because they all lose money, except sequencers. So sequencers, if they want to do some invalid withdrawal, also fraudulent withdrawal from the states by requesting, by submitting a wrong state roots and fabricate some wrong transaction information, transaction Merkle tree on the layer 1 when they do the first initial roll up. The cost of ensuring that data availability is still finite because of the pausing. Once they pause, the sequencer can no longer introduce more stash roots, more transactions. So there are a finite number of data availability requests that verifiers need to do to make sure that the unhonest behavior the sequencer is doing can be caught and be slashed. And the verifiers will get the bound from the sequencer as a reward. So all the cost the verifier has incurred during the data availability request can be covered. And that's how, that's why we call optimistic data availability. It is an entirely new concept, an interesting experiment I said yesterday. And I'm very interesting to know how the community reacts to it and whether we're gonna see bad players in the system. Because, okay, definitely there's some latencies, definitely not running on Metis. okay? Because in contrary to anyone's first impression when they hear this news, there's actually no security trade-offs. There's a big trade-off in the gas price consistency. Right now, you say, yeah, because we all trust Metis as a L2 operator runners, so we'll definitely make data available through our partner in Memo Labs. It's a distributed storage, just like IPF is Swamp. So data will be available, public viewable, so anyone can see it. You trust us, we deliver. That's how it does. So just like as us, if you trust us, we can make it available off-chain, cut all the costs, make it super cheap. That's what we have right now. But eventually, for the remainder of my topic, once we decentralize the sequencers, so Metis is no longer the sole credit L2 operators, things get a little bit tricky. So if we have bad sequencers, if we have malicious verifiers try to increase the number of data availability requests, the overall cost will actually rise. And I calculated in the worst case, the overall cost of making sure the data availability is there on L1 to ensure the security of the chain, if there are many, many bad players in the system, is actually higher than the current design of other optimistic rollups. So this is the trade-off we're making here. And I'm very interested to know whether we're gonna see a lot of bad players in the system. That's why I also said it's almost like an experiment. And that's what I want to say about the optimistic data availability. It's a new concept. You heard first here on the stage. Now, going back to my okay, I'm just gonna use the laptop, I would say. My graphical slides. By the way, I'm pretty bad at making slides. I don't make fancy slides like the rest of the presenters. Sorry about that. But this is the most graphical slide I have in today's talk. So there was a panel in the morning. I think everyone heard about it. There's definitely some centralization going on with all the top layer 2 operators. John from Fuel Lab maybe have a word, but most of the top layer 2 has a centralized sequencer as the operator. So most of the projects are well-funded by the investors. And really, to me, this is a hot take. It is like a scaling service to Ethereum. Like we're running a business, running a kind of we're providing a scaling service. So you can run your transaction pretty fast and pretty cheap, and backed by the Ethereum security model. At the same time, there's a very strong demand from the market. All users want low fee, as low as possible, and the transaction as fast as possible. So that I think every project has heard that. Even when we first came out, along with Optimism and other rollup chains, the transaction cost is around $1 or $2, which is already significantly less than Ethereum cost. Still too high. We heard so many complaints from users. Why is it so expensive? So the demand for low fee and fast transaction is still there. And that also, so I did have a chat with Ad, because they actually add the sequencer mode as a, I would say afterthought, but it's a kind of a thing that they didn't design initially. Really because the sequencer mode enables the lower fee and the fast transactions, and that's what the market wants. If we don't have it, layer 2 cannot survive very well, unfortunately. So there's a reason why there's some certain centralizations going on. I should use that. Okay, so I have listed some of the potential risks to various degrees. So it's not universal to every single chain out there, every single solution side. So I'm just listing out some of the common concerns they may run into. So like I said, the sequencer is a trusted entity right now. Most of the solutions has that. So you may run into potential MEVs. Again, thank you for trust Metis and thank you for trust Arbitron and Optimism. I don't think none of the projects tried to extract MEV from it. We're just honestly sequencing the transactions. But of course, people may always wonder whether we do that or we don't. But then censorship, very interesting topic there. So censorship is, I don't think any chain will do a permanent censorship. I don't think any chain can do it. There's a false inclusion mechanism that you can ensure that if sequencer kind of censor your transaction, you can force that transaction in eventually on layer 1. But I consider there's a temporary censorship that is still possible, right? So if all the other layer 2 transactions are pretty fast and being executed by the sequencer, when the sequencer gets it, somehow the sequencer doesn't like you and they want to censor your transaction, even though you can include it later on, but hey, you're already late for a lot of things. So there are potential explorations that may become a problem with this temporary censorship. And also requires continuous funding. Again, all teams need funding to continue operating. Running a sequencer is not too expensive, but there are a lot of components around it. It costs a lot of money. I can tell you that it's not easy to run a layer 2 solution that is scalable and be able to handle the vast amount of requests, not just the transactions, also all the RPC-related requests and stuff. So there are a lot of networking, there are a lot of cloud technology that we have to employ, and CI/CD, all that other stuff. They all cost money. It may not be transparent to the users, but they all cost money. Along with the development team, we still do innovations. There are a lot of things. For example, the optimistic data availability is something that we develop internally that requires money. And we have rollup cost. We still have to pay Ethereum, not pay Ethereum, but we pay the miners of Ethereum to get our data and to get the state roots on layer 1. So all those costs requires money. And if we don't have a good profit margin, then our funding can be a problem. So it requires continuous funding, and like I said, it's almost like running a business now. As long as we centralizely operating those solutions, we are a business. So basically, we're charging users a service fee so that we provide a fast and cheap transactions for our users to do whatever on the blockchain, and that's what the business is for. My concern is, maybe a hot take, right now I don't think any project is this, but eventually I fear that may come into this way. So instead of being a community-driven project, it becomes profit-driven, becomes more greedy, and becomes more like the centralized superpowers we have in the Web 2 world, all those enterprises, Amazon and Google and stuff. So that's my fear, but it's not the case right now, but again, there's a risk of going there. And finally, the availability. So if the sequencer is down, everyone has experience of that, I'm pretty sure. The network is basically halted. The only way you can interact with the network, I think, is through the inbox mode. And the inbox mode is expensive, slow, a long delay of confirmation. So there are a lot of problems with that. So the availability is definitely a problem. For certain solutions, if the sequence is down, you actually cannot withdraw anything. That can be another big problem. Mindful about the time. Okay, so our end goal at Metis is a community-operated layer 2 solutions. It is a grand goal, by the way. We're nowhere near close to it. We are trying to decentralize bit by bit. And it's very dangerous, actually, in my other talk earlier today. It is very dangerous to just give every decision power to the community. There are a lot of checks, a lot of security things we have to be careful with, especially when dealing with infrastructure. But seriously, I don't know if I can present Metis or not, but at least I personally, I do not want to operate a layer 2 node indefinitely. I don't think that's the vision we have. We want to focus on a lot of the Web 2 integrations. We want to focus on the mainstream adoption of Web technology. That's what we want to focus on. Keep running a L2 infrastructure is definitely a drag of our resources. Hopefully, we can find a way to decentralize in a way that our community members can actually help running the network together. And that's why we're focusing so much on decentralizing layer 2s. So, to set expectation, I don't think I have a solution for everything. I don't have a solution for a lot of challenges I'm going to list. But really, for this presentation, I want to list out some things we have considered as challenges and certain ideas we have tried and discussed internally. So to take this opportunity to talk to the community so everyone can start thinking about those problems, and love to hear if you have some research that relate to those challenges and have some solutions, love to hear offline. We have had some discussions, and I will buy you a drink. Okay, so first, for layer 2s, something interesting I heard today about Arbitron's plan for is that the sequencer feed consensus. It is interesting, I would say. Sparked some thought of mine, been thinking, what about this slides? So usually on layer 2, there's no block consensus because with consensus means there's a delay in confirmation. You won't get the same lightning fast speed that you usually get with Optimism, with Metis, and with other rollups that you have. So I definitely need to talk to Az about the sequencer feed afterwards. But there's actually no need for block consensus for rollups. Why? Because the security is backed by Ethereum. So if the sequencer is not producing block honestly, there's a way to challenge, or there's a way, or you won't be able to generate the validity proof in order to confirm the transaction. So that's why rollup doesn't need the block consensus. But that makes the decentralization a little bit tricky. Why? So there's a design called block proposers. So what it means is instead of just sequencer proposing the state roots, it opens up to the communities. So basically anyone with a stake can start to propose blocks, and anyone can hold a copy of the states by calculating the transaction data made available by the sequencer, all that. The problem is that we tried it. The problem is there are certain concerns about confirmation delays because Ethereum also have need some time to confirm the transactions. We have to consider when we say the layer 2s are backed by the security of layer 1. Layer 1 can be attacked for a certain amount of time. It's not a bulletproof. You need certain number of blocks in order to confirm transactions. So if we do the block process, there will be a lot of possibilities that we may have to do rollback on layer 2. So these are things that we were discussing internally. I was wondering whether whether this is a good direction to go. So again, some thoughts. Another thing that we tried, actually implemented within Metis, is a kind of I won't say it's a full-fledged peer network. It's kind of a pouch-down peer network. The way we do is the sequencer produce a block with a special signature attached to it and broadcast to the rest of the network. The sequencer is incentivized to broadcast this block because we do not allow any direct transaction be submitted directly to the sequencer. So the sequencer is actually a hiding behind a vast network of peers, I would say peers, or full nodes. So that the full nodes will actually submit the transactions to sequencer through a special mechanism. So if sequencer stop broadcasting the blocks to the rest of the tier network, they actually don't get any transactions in, and they don't get the gas fees and collections and others. So they're actually not incentive. So they're whatever. So discouraged by not to broadcast the blocks to the rest of the network. But still, there are quite enough things we have to do because it changes how the current Ethereum P2P network works. We actually put a lot of efforts to change the the transaction metadata in order to make it work, especially the signature part. That's an addition to what Ethereum offers. And also because when we need to decentralize sequencers, it also means that sometimes a sequencer may not be a valid sequencer anymore. So this role is no longer valid. Just like in the beginning, I said pausing the sequencer role. So this particular entity can no longer be a sequencer, so you have to strip the role of it. That mechanism requires a L1 transaction so that the manager contract will actually have a record of who is the valid sequencers in the pool and be able to decentralize it that way. And all the peers will read from the L1 contract, understanding what are the valid signatures I'm expecting from this peer network, so that they will know, hey, what blocks to accept and what blocks to reject before they even try to validate the transaction. So the beauty of a peer network is every peer node, once they get the block, they will definitely do a block validation, because that's part of the Ethereum network, Ethereum code base. So they will get the transactions and they'll do the validation, make sure that all the blocks is actually be produced by the producer faithfully and honestly. And if anything happens, they can actually stop the network in a way that the peers will stop talking with that particular sequencer that's not honest. Next challenge is actually very interesting. I don't know if I have another one. Okay, probably missed it. So I don't know if any projects dealing with gaming a lot. There's a big demand regarding timestamps. Actually, a lot of game projects complained about the way we handle timestamps. Is it about time? 3 minutes? Almost there. So about time, there's a big delay in our first version, about 3 minutes delay, because we're trying to tie the timestamp with L1 timestamp for that particular rollup transactions. The problem is, again, L1, I can tell you, it's constantly changing in terms of the blocks, the timestamp. You have to wait for 12 blocks in order to get that confirmation. You have a confidence that, okay, this is the timestamp for that particular block, mostly related to the RPC providers and network mining disputes and stuff. Don't want to get into details, but you have to wait for a while in order to actually know exactly what the timestamp of that particular L1 block is. That's unfortunate. And that contributes to the almost 3 minutes delay for a lot of solutions you're seeing that using options rollup. That 3 minutes delay is actually devastating in a lot of cases. So for lending, for gaming, and for IDOs, auctions, so there are a lot of projects rely on like real life time for certain things. They will have a lot of trouble following the current timestamp design. So we have to, I think we have to break that tie, but then we need a way to sync the timestamp among the sequencers, making sure that a sequencer is not trying to take advantage of the smart contract by fabricating certain special timestamps that they're trying to broadcast. I don't have too much time to expand, but happy to talk offline about this. Finally, this is something I defined. By the way, this is related to the second challenge, because once we start to break that tie to the layer 1 block timestamp, we found this. So this is actually interesting. So when we calculate the state roots of a transaction, giving the same state, if the timestamp of that particular transaction is different, you may still get the same state. Depends on what transaction is. So if the timestamp cannot be properly synced and kind of attached to a certain L1 block, you may get into a situation where the state root says, oh, it matches, but actually the block is already different. So there's actually a demand to do block verification, not just rely on the state root verification. Okay, so these are the things that we found so far on this crusade to decentralize L2. Hopefully it is useful. I don't think there are too much time for questions, but I'm willing to take if you have one.
No, unfortunately, we do not have time for questions, but instead, please, a big round of applause